Assalamu alaikum dear viewers, hope you are doing well. I am Shoaib and Dayo again here with another informative and interesting video related to the electrical machines lab. Dear viewers, today we are going to perform the experiment regarding the series wound motor operation on this electrical machine trainer. So today Mr. Huzaifa is with us and Mr. Faraz is with us. Sir, both of you, I welcome you in my YouTube channel. So before doing this experiment, let's discuss some few points regarding the series wound motor. So in the series wound motor, in which the field winding is connected in series with the armature winding. Therefore, the series field winding carries the armature current, since current passing through the series field winding is same as that of the armature current. So it must be designed with the fewer number of the turns of the thicker wire than the shunt field winding for the same m.m.f. having the low resistance. So in the series wound motor, the armature current is equal to the series field current is equal to the line current and is equal to the total current of the electrical machine. And if you want to calculate the power drawn from the main supply, in the case of the series wound motor, so it is the product of the supply voltage multiplied by the line current. So now dear viewers, you can see this is the circuit diagram of the DC series wound motor that we have to implement on this electrical machine trainer. So you can see according to this circuit diagram, the series field winding is connected in series with the armature winding. So that's why it is called as the series wound motor. So dear viewers, without wasting time, let's implement this circuit diagram on this electrical machine trainer and observe the results of the different parameters like the armature current, the series field current, the line current and power drawn from the main supply, even the power developed in the armature in the case of the series wound motor operation. So now first we have to connect the supply voltage to the armature terminals of the DC series wound motor, and before connecting with the armature terminal we need to connect the variable resistance in series with the armature terminals, so that it can limit the starting current of the DC series wound motor. So first we need to connect the DC voltage supply to this armature resistance, okay, and this will be connected in series with this ammeter. So now when this ammeter is connected in series with the armature winding and also the armature winding is connected in series with the field winding, so the function of this ammeter will give us the value of the series field current, of the armature current and also the field current of the whole DC series wound machine, okay, and connect this terminal of the ammeter with the positive of the armature winding, okay. Now connect the armature winding in series with the series field winding, okay, and now connect the negative terminal of the series field winding with the negative terminal of the DC supply. So now if we want to measure the voltage available across the armature terminals, so we need to connect the voltmeter in parallel across the armature terminal. So this is the DC voltmeter, okay. So now this is the armature winding. So now connect the voltmeter in parallel with this armature winding. So this voltmeter will give us the value of the back EMF or the counter EMF which is produced in the armature terminals of the DC series wound machine, or the voltage available across the armature terminal in the case of the DC series wound motor. And now also we have to connect the mechanical load with this series wound motor. So the function of the DC series wound motor is to convert the DC electrical power into the mechanical power. So we are connecting the load with the DC series wound machine, okay. So dear viewers, our experiment is ready on the electrical machine trainer. So now start this trainer and observe the values of the back EMF, the armature current which is the same as the series field current, and also the line current in the case of the DC series wound machine. So start this trainer, okay. So now you can see we are giving the 80 voltage DC voltage to the armature terminals of this DC series wound machine, and now this is the armature current and which is the 2 ampere. So now this is the 2 ampere current, means this is the total line current of the machine, because in the series wound machine the line current is equal to the series field current is equal to the armature current in the case of the DC series wound machine, and this is the almost 30 volt or the 29 volt is the voltage available across the armature terminal, which is the back EMF. Okay, so now Josefa, if we want to calculate the power drawn from the main supply in the case of the DC series wound motor, so it is the product of the supply voltage multiplied by this armature current. So supply voltage is 80 volt almost, and the armature current is 2 ampere.
So 160.
Means the series wound motor in this experiment is 160 watt power drawn from the main supply, and if we want to calculate the power developed in the armature terminal, so it will be the product of the back EMF multiplied by the again your line current. So back EMF is almost 29 volt and the armature current or the line current is 2 ampere.
58.
Okay, so means the power drawn from the main supply in the case of the DC series wound motor is the 160 watt, and the power developed in the armature is the product of the back EMF multiplied by this line current, where this is the line current, this is the armature current, and this is the series field current of the DC series wound machine, and the power developed in the armature terminal is the product of the back EMF multiplied by this armature current, which is the same as the line current, so which is almost 58 watts. Okay. So dear viewers, this was the experiment regarding the DC series wound motor that we have done on this electrical machine strainer, in which we have observed the results of the different parameters like the armature current, the series field current, and also the line current, because in the series wound motor line current is equal to the armature current is equal to the series field current in the case of the DC series wound machine, and also we have observed the results of the power drawn from the main supply, which is the product of the supply voltage multiplied by the line current, and also we have calculated the value of the power developed in the armature terminals, so which is the product of the back EMF multiplied by the armature current or the line current. So dear viewers, this was the experiment of the DC series wound motor that we have done on the electrical machine strainer. I hope that you have enjoyed today's experiment. So at the last, do subscribe my YouTube channel Shoaib Dayo for more informative videos related to the electrical engineering, electrical machines, power electronics area. Thank you very much.